Hello everyone. Today we are going to discuss class 6 science chapter 4 exploring magnets MCQs. All the MCQs are based on latest syllabus and they are important for easy learning and remembering. Do attempt the MCQs and do not forget to comment down your score. Let's start. Which of the following is a magnetic material? We know magnetic materials are materials which get attracted towards a magnet. So the answer is iron. Which of the following is a non-magnetic material? We know iron, nickel and cobalt. They are magnetic materials. So the answer is plastic. Which pair contains only magnetic materials? So the answer is iron and nickel. Materials that are attracted towards a magnet are called magnetic materials. Which metal is not listed as a magnetic material? We just now discussed iron, nickel and cobalt are magnetic materials. So the answer is aluminium. Which object is most likely to be attracted by a magnet? Steel pin. A material that is not attracted towards a magnet is called non-magnetic. Lodestones are naturally occurring magnets. The magnets commonly used in toys, pencil boxes and laboratories are generally artificial magnets. Where do iron filings stick most strongly on a bar magnet? We have seen that it sticks more near the ends. The two ends of a magnet are called poles. A magnet has north and south pole. Which statement about the poles of a magnet is correct? Poles always occur in pair. We know that there cannot be a magnet with a single pole. Every time each magnet has two poles. If a bar magnet is broken into two pieces, each piece will have both north and south poles. Which experiment helps identify the poles of a magnet more clearly? Using iron fillings. Which part of a bar magnet attracts the largest number of iron fillings? It is the ends or the poles. Can a magnet with only a north pole be obtained by breaking a magnet? No. We know there cannot be a magnet with one pole. What happens when a bar magnet is freely suspended? It points north, south. The pole that points towards the north direction is called north seeking pole. The end pointing towards the south direction is called south seeking pole. Why does a freely suspended magnet align north-south? Because Earth also behaves like a giant magnet. A freely suspended ordinary iron bar will rest in any direction. Since it is not a magnet, it will not align itself in north-south direction. The property of a freely suspended magnet is useful for finding directions. We can find out north-south alignment. Which instrument uses a freely rotating magnetized needle? It is magnetic compass. The needle of a magnetic compass indicates north-south direction. The north pointing end of a compass needle is usually painted red. A compass needle should be allowed to rotate freely. Which ancient Indian device was used for navigation at sea and was similar to a magnetic compass? It was Matsya Yantra, where needle was shaped in the form of fish. So it was called Matsya Yantra. What happens when north pole of one magnet is brought near the south pole of another? We know that these are unlike poles. North pole and south pole, they are going to attract. When unlike poles come towards each other, they attract. And if it is like poles, they repel. What happens when north pole is brought near north pole? Now we have same pole, so there will be repulsion. South pole near south pole will result in repulsion. Which pair of poles will attract? North, south. Which property can be used to distinguish a magnet from an ordinary iron bar? It is repulsion. Iron bar is attracted by both the poles, whereas a magnet only can show repulsion with like pole. So repulsion is the sure test to find out any magnet. An iron bar is brought near the north pole of a magnet. What will happen? It will be attracted. A magnet is brought near another magnet and the two of them move away from each other. This indicates that like poles are facing each other because there is repulsion. If two magnets move towards each other, the facing poles are unlike. That is why we are seeing attraction. Which is the correct statement? Like poles attract and unlike poles repel. No. Like poles repel and unlike poles attract. Why does a bar magnet attract more steel U-pins near its end? Because its magnetic effect is stronger at its poles. If a bar magnet is rolled over a heap of U clips, where will the largest number of clicks collected? It is near the ends. Three identical metal bars are given. Two are magnets and one is an iron bar. Which property can help us identify magnets? It is repulsion. Why is attraction alone not enough to identify an object as a magnet? Because an ordinary iron bar can also get attracted towards a magnet. So, attraction is not a sure test for finding a magnet. A magnet can move some magnetic objects without touching them. A steel ball is placed inside a cardboard maze. How can it be moved without touching it directly? By moving a magnet below the cardboard. The steel ball will get attracted and move along with the magnet. A steel paper clip falls into water. How can it be removed without getting your fingers wet? We can use a magnet. What happens to the magnetic effect when a sheet of wood is placed between a magnet and a compass needle? There is no change because we know that magnetic effect can act through non-magnetic. A compass needle moves away from the north pole of a bar magnet when it is brought near its north pole. Why? Because like poles repel each other. If the south pole of a bar magnet is brought near the north pole of the compass needle, what will happen? They will move closer because there will be attraction. An iron swing needle can be converted into a magnet by repeatedly stroking it with one pole of a magnet. In the activity of magnetizing the needle, the process is repeated approximately 30 to 40 times. After magnetizing the needle, what can be used to check whether it has become a magnet? We can check it with the help of iron fillings or steel pins. If it will attract, it has become a magnet. Otherwise, it has not. This is all from my side. I hope you enjoyed the video. Do like and share the video and do not forget to subscribe the channel. Stay tuned to the Curious Lab where you ask, explore and discover. Thank you.